This is a video showing how to do some of the problems from the assignment. So you have to do pages 210 through 211, and it's numbers 2, 5 through 12, and let me double check the last one here, 5 through 12 and 15 through 20. So 2, 5 through 12, and 15 through 20. So let's start with going through just some of these. I'm going to have you do number 2. You have to tell which one of these does not belong with the other three. Then on 5 through 12, let's start with this little section here, 5 through 8. I'll do number 5 for you. So it says tell whether the triangles are similar. Remember, similar triangles have all of the same angle measures. So all of the angle measures are congruent. So you're given 2 angles, you're missing 1, and then you're given 2 other angles and you're missing 1. So we can match up the 39 with the 39. We know we have that angle measure. We don't know if we have this one being 107 and this one being 34. So that's what we have to figure out. But remember, all the angles in a triangle, they add up to 180 degrees. So if I say 39 plus 34 plus x, they must add up to 180 degrees. Same thing with this triangle. If I say 107 plus 39 plus y, again, they must add up to 180 degrees. The interior angle sum of a triangle is always 180. So here we're going to solve this equation. First off, combine like terms. So we get 73 plus x is 180. Subtract off the 73 from both sides of the equation. That will cancel out. We get x equals 107. So this one right here, this is 107. Well, if you have 107 there, you have 107 here, you have 39 there, you have 39 there. The only other option to make a triangle to add up all these angles to add up to 180 is if you have a 34-degree angle. So we have 39, 107, 39, 107. We have to have 34 in that last spot. So this one right here has to be 34 degrees. So are they similar? I can't type on this one to write with my mouse. I'm going to say yes, the triangles are similar. Triangles, that's a triangle symbol. The triangles are similar since all angle measures are congruent. You could also say something like, since the triangles contain the same angle measures. But the idea is, to be similar, all the angles have to be the same in each of these triangles. So these 3 angles must also be found in this triangle. So you'll do the same process on the other questions here. All right, going on to, I'll leave that one up to you. Double check this again. We have 5 through 12 and then 15 through 20. Okay, the triangles are similar. Find x. For these problems, I'm not necessarily going to give you the answers, but don't overthink them. It says they're similar, so remember, you can just match up the angles. So what does x match up with? Does it match up with 50 or does it match up with 20? All right. Number 12. We can do number 12 together. All right, so number 12, it says the map shows the number of steps you must take to get to the treasure. So here you are, and you're going to be walking, you're going to try to find, oh, you got to go this way. It's 300 steps to the palm tree, 240 steps to this river, 80 steps from the river to the pyramids, and then we don't know how many steps we're going to have to take to get up to that treasure, so let's call this distance x. So x up here marks the spot, but we're going to call this distance x. So this problem is very similar to the one I had in the lesson about finding the distance across a pond. We have 2 triangles here, and we've got similar triangles. We've got these vertical angles right here. We have 2 90-degree angles, 2 right angles. So the amount of degrees left for these last 2 angles must be the same. So these are similar triangles. So what we're going to do is use indirect measurement by setting up a proportion. So my large triangle here, let me just redraw this. My large triangle, the vertical side here is 300 steps. So if I just flip it over, this is 300 steps here. The horizontal The horizontal piece is 240 steps. And then I've got my small triangle. So if I just flip this over, my vertical piece is x steps and my horizontal piece is 80 steps. So I've got two similar triangles I can set up a proportion, and from that lesson I told you it's always easiest if you start with the variable. So I'm going to do my work over here. I'm going to start with my variable x. I'm going to divide by the other side length, 80. So I started with the vertical piece, I divided by the horizontal, so I'm going to say it must equal the vertical divided by the horizontal, 300 divided by 240. 300 divided by 240. So they have to be in the same relative positions. If you start with the vertical piece in the numerator there, you've got to use the vertical piece in the numerator on this one. The horizontal piece in the denominator, so the horizontal piece in the denominator. And then we have to solve this equation. So we're going to multiply both sides by 80. I'm just going to rewrite my first step here. Show that I'm multiplying both sides of the equation by 80 to undo the dividing by 80. Remember, anything you do to one side of an equation, you must do to the other. Those cancel. X is by itself. And don't forget, if you're multiplying by whole numbers, it's the same thing as the whole number over 1. And to multiply fractions, we multiply the fractions straight across. So 300 times 80 is 24 with 3 zeros, 24,000. 240 times 1 is 240. And we're going to end up with x equals 100. And again, we're dealing with steps, so this is 100 steps. And that's our answer. So the question ultimately says, how many steps do you take from the pyramids to the treasure? 100 steps. So this is 100 steps. There you go. There's number 12. So one last time here, we had 15 through 20 as well. So 15 through 20. Number 15 is a fairly complex problem. I want to point out a few things on here. I'm not going to do this one for you, but I'm going to guide you to get started. I highly recommend you break this up into 3 different triangles. So ultimately it says this drawing board, the drawing shows the scoring zone of a standard shuffleboard. So this is a game, I don't know if you've ever seen this, but there's little discs that you slide on the ground. So this is the standard zone of a shuffleboard court. It says right here, this is key to the problem. It says that you've got a bunch of similar triangles. Triangle DAE. D, that's right here, DAE. So triangle DAE, that's the large triangle. So triangle DAE, right here, and it gives you a side length of 9.48. 9.48. The lengths of segments, oh, sorry, I'm going to keep going here. You can break this down into 2 smaller triangles here. You have ACF, ACF, ACF. And for that ACF, we don't know the length of either of these sides yet, at least with the given information that I've read so far. And then here, ABG, ABG. So I highly recommend you write all of this down on your paper. ABG, we are given that this is X. BG, segment BG is length X. The base of the large triangle, I didn't put this down already, it's 6 feet, so I'm going to put a 6 here. And okay, so let's look at this diagram a little bit more. If this whole side here is 9.48 feet, and this is 6.32 feet, this piece right from here to here is 6.32 feet, we can figure out how long this one must be. So we're going to take the big length of this side length, the overall length of the long side here, which is 9.48 feet, and then we're going to subtract off 6.32 feet. So we're going to take 9.48 feet, 9.48 feet, and we're going to subtract off 6.32 feet, and we get 3.16. So this little length right here is 3.16 feet. That's the length of segment AB. So AB right here is 3.16 feet. So this side over here is also 3.16. And it says right here, the lengths of segments AG, GF, and FE are all equal. So AG, GF, and FE are all equal. So this one, and this one are all the same length. Well, if all of these together give you 9.48, if you were to divide that into three pieces, I'll just show you here. I already know what that's going to give me, but 9.48 divided by 3, that's the 3.16 again. So each one of these pieces is 3.16 feet. So on this medium-sized triangle, triangle ACF, this is 3.16 and that's 3.16. So if I've got two 3.16s, so I just do 2 times 3.16, I get 6.32. That's the length of this side and this side. And this one right here is also 9.48. That's my large triangle. That's the ADE triangle. So that's what I'm going to start by giving you. It says all the triangles are similar. Remember this symbol here means similar. So we know that all of their angle measures are the same. They're all similar, which allows us to set up a proportion. So I'm not going to give you any more on this. Ultimately, part A says find X and part B says find CF. So we want to know this one. So let's just, I don't know, call this one, pick a letter, any letter. How about M? So I want to find X, just this side length here, and I want to find the length of side length M, or you could call it CF. So you could say CF equals, and then you could find that measurement, and it's in feet. And you also have to find X. But I don't want to go through the rest of that one. So I got you started. Hopefully that's enough. Some of you are going to have to reread this a couple of times. You're going to have to really look at this diagram. You'll probably have to draw this out yourself and try to set up some of those proportions. So try your best, see what you can do with it. All right, so what else was there? There was 15 through 20. So does the equation represent a linear or nonlinear function? This is review. So this is review. Does it represent a linear or nonlinear function? Remember, linear functions can all be written in the form y equals mx plus b. If it's nonlinear, then you cannot write it in y equals mx plus b. If it is linear, then you can write it in y equals mx plus b. So like this one, this is y equals 1 divided by x times 5, or 5 times 1 over x. It's not y equals 5x, it's 5 times 1 over x. So this is not y equals mx plus b. So I'd say this is nonlinear. Since it can't be written in slope-intercept form. And slope-intercept form is y equals mx plus b. So I'll just put in y equals mx plus b. There we go. So that's why it's nonlinear. So you're just trying to see, is it y equals mx plus b? If it is, then it's linear. If it's not, then it's nonlinear. Remember, for this one, you could put plus a negative 8. So this is y equals 2x plus a negative 8. All right. Number 20, the last one you have to do, it says which two lines are parallel. Remember, parallel lines have the same slope. So you're looking for which two of these lines have the same slope. So hopefully that's enough to get started. If you have any questions, you know what to do. Thank you.